Good evening, students. Today in thermodynamics, we will study the state variables and equation of state. To understand that, first we need to understand what is equilibrium state. The equilibrium state of thermodynamic system is completely described by specific values of some macroscopic variables. When we are talking about microscopic variables, that we also can say state variables. What are they? They are pressure, volume, temperature and mass. Okay, so to understand the equilibrium state, we need to know we need to know the macroscopic variables that is also called state variables. These state variables are pressure, volume, temperature, mass, and if it is a mixture of gases, then composition. Okay, if the mixture, then composition. Then it is composition also. We need to understand once that a thermodynamic system is not always in equilibrium. For example, let's say in this diagram I have a part filled by a gas. Okay. Let's say figure 1. In figure 1, if I suddenly remove this partition, if I remove suddenly this partition, then what will happen? This lead to free expansion of the gas. Okay, if I remove this partition, then this will lead to free expansion of the gas available in this chamber. So gas, if allowed to expand freely against vacuum, then this is not an equilibrium state. Okay, so if a gas allowed to expand freely against vacuum, then this is example of non-equilibrium state. Okay, is not an equilibrium state. We can take one more example in this regard. For example, a mixture of petroleum, vapor and air when ignited by a spark is not a equilibrium state because temperature pressure are not uniform. So when gas attains a uniform temperature, pressure and comes to a thermal and mechanical equilibrium with the surrounding, then we call that state is a state of equilibrium. Hope that would be clear to you. To understand more deeply, first, we need to understand that there is all these state variables are of two kinds. Okay, so we have divided state variables in two kinds. The first one is extensive. Okay, let's say type variables. First one extensive, second is intensive. Extensive variables indicate the size of the system. Intensive variables do not indicate the size. What would be the example of intensive? Pressure, temperature, are few examples of intensive variables. For example, let's we think about a relevant system in equilibrium and imagine that it is divided into two equal parts. The variable remain unchanged in each part are intensive. Okay, let's say we have a system and this system is in equilibrium. That means the gas has attained a uniform temperature, pressure, and it is in thermal and mechanical equilibrium with its surroundings. So to understand the state variables, let's say I have divided it into two equal parts. And the variable that remain unchanged in each part are intensive. That is pressure, temperature, and there are few variables whose value will get halved in each part. Okay, value will be halved in each part. Those will be nothing but those variable will be nothing but extensive. Okay, okay. These variable will be. I'm repeating again. Please pay attention. If I am taking a system which is in equilibrium and dividing it into two parts, the variable that remain unchanged in each part are intensive and the variable whose value get halved in each part are extensive. The example of extensive variables is internal energy, volume, mass, and these are, as I am dividing the system into two parts, the internal energy, volume and mass will be halved. The value of these variables will be halved. So these are extensive variables. And the connection now, after understanding these state variables, we'll move to the equation of state. The equation of state would be dV is equal to mu R T. For a fixed amount of gas, the mu will be given. Here we have only two independent variables, say P or V or T or V. The pressure volume curve for a fixed temperature will be called isotherm. The real gases may have more complicated equation of state.